Hey ladies and gentlemen, I'm once again back to take you through some online lectures. Yesterday we talked about mutually exclusive events and we also briefly talked about conditional probability. So today we want to continue looking at conditional probability and see how we apply this in daily life. Remember that conditional probability, we are looking at two events. The occurrence of one affects the probability of the other. And we said that we write this if the events are A and B, okay? Then probability of A, given that B has occurred, is probability of A intersection B over probability of B, okay? We discussed this in the most recent lesson. Probability of A given B is probability of A intersection B over probability of B. So from here we can get the intersection and say that probability of A intersection B is the probability of A given B times probability of B. Okay, and that result is so important in probability. Also, one can say that the probability of B given that event A has occurred is the probability of B intersection A over probability of A. Okay, so we can see that the probability of B intersection A, okay, will be probability of B given A, then times probability of A. Okay. We also know that since the probability of A intersection B is the same thing as the probability of B intersection A, okay, then we can conclude that the probability of A given B times probability of B is the same thing as the probability of B given A times the probability of A, and these two, n of these two will give you the intersection. Okay, so this is also important in probability and we might make use of it. So highlight it before we start looking at examples. Look at this question. It says in a certain school, 65% of the students are full-time students. 55% of the students are female. 35% of the students are male full-time students. Now they are giving us some question. Find the probability that a student chosen at random from all the students in the school is a part-time student. Okay, so that's the first part. Normally, it is a good practice to read and understand the questions before you attempt to answer. Okay, when you look at this question, the first part is demanding you to find the probability that a student chosen at random, okay, is a part-time student. They have given us some information about full-time students. Okay, so in this school, you are either full-time or part-time, but you cannot be both. Okay, in a normal school setting, you are either a full-time student or you are a part-time student. Okay, you come to school for a few hours and go and do some other business, or you stay at school most of your day and then later on in the evening you just go back home. That's what we call a full-time student. Okay, so you can't be both. You can't be full-time and part-time. No. Okay, now if you want to be full-time, you are part-time. So let's answer the first part of the question. So to answer the first part of this question, we must have some idea about what we call complementary events. Okay, the probability of full-time, okay, plus probability of not full-time. This is equal to 1. But if you're not full-time, you are part-time. So this is the same thing as writing P of part-time. And the first part is asking a student chosen at random for most students in the college is a part-time student. So the probability of part-time student is 1 minus the probability of full-time. Okay, so what is it? 1 minus 0.65. You're gonna get 0.35 as the answer, the first part of the question, and it is solved. So the probability that somebody is part-time is 0.35. Then part B, okay, part B is demanding for a student chosen at random from the students in the college is a female and a part-time student. So to get part B, we would use this fact that the probability of full time, okay, is the probability of male and full time plus the probability of female and full time, okay. And this probability was given for a full-time student 0.65, okay. The male that are full-time students make 35%, this is 0.35 plus the probability of female and full-time, okay. So what does it mean? This means that the probability of female, okay, and the full-time is 0.30, okay. So the question is asking us to find the probability of female and the part-time, but we know that the probability of female, okay, there are two categories of the female students in this school. There are those that are female and full-time, then there are those that are female and part-time, okay. So the probability of female, okay, and the part-time will be 0.55 minus 0.30, okay, 0.55, because the probability of female is 0. Female, okay. Then female and the full-time, we are discovering that these are 0.3, okay. So we get the answer as 0.25. 0.25. Now let's look at part C. Okay, they wanna find the probability of student chosen at random from the female student. Now this is conditional, okay, and you have to be careful with the conditional probability question. Is you may fail to interpret this question. The question says the probability student chosen at random from the female students. So the condition is we are picking from the female students, and what the probability the students we're going to choose is a female part-time student. So we are looking at the part-time. This is a part-time given female. Okay, how do we define this? We define this as the probability of part-time intersection the female, okay, then this is divided by the probability of the female, and the part B gave us the probability of female and the part-time, that was 0.25. divided by 0.55, because the probability of the female students in this school is 0.55. So let's try to calculate this. 0.25 over 0.55, the same thing as 25 divided by 55. Okay, 25 over 55, if you want this in the lowest terms, is 5 over 11. Okay, you get 5 divided by 11, and 11 goes in 5 4 times. Okay, if you want to put this in decimals, 0.4, that is 44. The remainder is 6. Okay, now 45, I think 0.45. Okay. So it's 0.454, it is a recurring decimal actually. So 5 over 11 is a better answer than writing 0.45 recurring, but that's the answer. That's the probability that a student chosen from the female students is a part-time student. Let's have another example and let's see what we can do about this. Maybe that was a bit hard. So example, and the example says that x and y are two events such that probability of x given y is 0.4. Probability of y is given as 0.25, and the probability of x equal to 0.2. So the question is, find A, probability of y given x, then B, probability of x intersection y, then C is the probability of x union y, conditional probability. So what do we do in the solution? So to answer this part A, there is an interesting result we just wrote down as we were discussing this. We said the probability of x intersection y, the same thing as the probability of x given y, okay, times p of y, which is exactly the same as the probability of y given x, okay, times the probability of x. Now, what does it mean? It means that the probability of y given x times the probability of x is equal to the probability of x given y times probability of y. Okay, so we can make a substitution here. The probability of y given x multiplied by p of x. P of x is given to us as 0.2. Okay, will be equal to the probability of x given y is 0.4 times the probability of y, which is 0.25. So if you make this the subject, probability of y given x, so this is y given x, will be 0.4 times 0.25 out of 0.2. Okay, so simplify this and you have the answer. Part B, we want the probability of x intersection y. Define this as the probability of x given y times probability of y. Okay, and the x given y is 0.4 times probability of y, which is 0.25. If you multiply 25 by 4, you get 100. So those are 3 decimal places, and the answer is 0.1. Okay, so part C, the probability of x union y. We shall look at the probability rule for combined events. This is the probability of x plus probability of y minus the probability of x intersection y. Okay, so x is 0.2. 0.2 plus 0.25 minus 0.1. Okay, so that's 0.35 as the answer. So that was really a very simple question. Okay, let's look at another example. All right, let's look at this example. A group of boys is entered for advanced level mathematics modules. Each boy takes only module M1 or M2 or both M1 and M2. The probability that a boy is taking M2 given that he's taking M1 is 1 over 5. The probability that a boy is taking M1 given that he's taking M2 is a third. Find the probability that a boy selected at random is taking both M1 and M2. Okay, that's part A. Then part B, a boy selected at random is taking only M1. So this question is a simple question, but because students try to avoid the kind of worded problems, okay, problems that require reading and understanding, most of the students will shy away from this question. But let's analyze it. Okay, it is conditional. The probability that a boy is taking M1 given that he's taking M2. Okay, so you have some information. If I'm writing here for you, this is what they are saying, that the probability of M2 given M1 is 1 over 5. And more information is coming from here. The probability of M1 given M2 is 1 over 3. Okay, so from that information, they want us to find the probability, okay, that a boy selected at random is taking both M1 and the M2. They are looking for the intersection. Okay, let's go about that. The intersection will come from the statement that says, okay, the probability that a boy, okay, a group of boys enter for advancing. The intersection will come from this step, okay, which says that each boy takes only module M1, okay, M2 or M1 and M or M1 and M2. Now, this means that we don't have any single boy who does not take any of these. So everybody lies in the union, and therefore the probability of the union is equal to 1. Such events, okay, where the union forms the whole probability is what we call exhaustive events. So with exhaustive events, the probability of M1 union M2 is going to be 1. So let's solve the problem right from there. We know that the probability of M1 union M2 from the probability for combined events, this is the probability of M1 plus the probability of M2 minus the probability of M1 intersection M2. Okay, now we have a challenge. Okay, we know that this is gonna be 1 because all the students take at least one of M1, M2, or both. Okay, so that is 1, but we don't have M1, we don't have probability of M2, and we are looking for the intersection. Okay, now that should not worry you so much. There is a reason why they are giving us this information. We know that the probability of M1, okay, given M2 times the probability of M2 is the same thing as the probability of M1 intersection M2. Okay, so what we can do, let's call this maybe Y. Okay, so that in our substitution we can have M1 given M2 is given as a third, okay, of probability of M2 is equal to Y. Okay, and this means that the probability of M2 is 3Y. Okay, also the probability of M2 given M1 times the probability of M1 okay, let me use multiplication, is equal to the probability of M1 intersection M2, and still to be equal to y. So we can make a substitution. This was given as 1 over 5 times the probability of M1, okay, is equal to y. So we have y. This means that the probability of M1, oh sorry, I'm writing M2, but this is supposed to be M1, okay? The probability of, let me try to erase some, the probability of M1 is gonna be 5y, okay? Now everything has been expressed in terms of y, remember, okay? We have let the probability of M1 intersection M2 be y. So that's why we are finding it very easy to make use of this step, substitute, okay? So that but the probability of M1 union M2 is equal to 1, okay? It is given from the question where they are saying that, okay, each boy takes only module 1 or only module 2 or both M1 and M2. So there is no single person, okay, from this group of boys that does not take any of M1 or M2. So outside the union, we don't have anybody. Everybody is in the union, and therefore the probability of the union is equal to 1. Okay, so let's make a substitution. 1 will be equal to, we are saying M1 is 5y, okay, and M2 is 2y, is 3y, then minus a y. So we are getting the intersection right away, okay, because y is the intersection. So we have y, that is 8 minus 1 is 7, y is equal to 1 out of 7. So therefore the probability of M1 intersection M2, okay, is 1 out of 7. We have got it, and that was the most difficult thing in this question. Now that we have it, we can answer the other part. A boy selected at random is taking only M1, okay? Let's do it the next page. So if you are to get a bit of M1 only, okay? Sometimes this can be written as probability of M1 intersecting M2 complement, okay? We must make use of the Venn diagrams. Let's make use of this Venn diagram. We have M1 and we also have M2. This is M1 and this is M2, okay? So we know that if we want this part, that is M1 intersection M2. Now, the good news is we can use any, okay, in this case, no, not any, but in this case, we know that this is M1 intersection M2 complement. So if you want the probability of M1, okay, you want what is in this circle, okay, it will be equal to the probability of M1 intersection M2 plus the probability of M1 intersection M2 complement, okay? So probability of M1, remember when we are expressing M1 in terms of y, this was 5 times y is equal to, okay, the probability of M1 and M2 was 1 out of 7. Remember y is equal to 1 out of 7, so this 5 out of 7 plus probability of M1 intersection M2 complement, okay? So what is y? This is 5 over 7 equal to 1 out of 7 plus probability of M1 intersection M2, meaning that the probability of M1 intersection M2 is 4 over 7 m2 complement, rather. This is a complement. Okay, so the probability of a boy selected and random is taking only, boy takes only m1, well, this m1, yes, takes only m1 is equal to 4 over 7, and that's done. Ladies and gentlemen, let's stop here with this discussion today. We have discussed conditional probability. There are lots of questions. If you check this book, I'm using a concise course in advanced level statistics by J. Crosh and J. Chambers. You will find this information in print, and you can solve so many problems. Fourth edition or third edition, any of those two books you can use and get to know what I'm talking about. So buy yourself a copy. You can get an online copy. These just cheap books you can find in a store anywhere in your country. So make sure you subscribe, share this information with a friend, and if you feel drop a comment, I'll always respond. Okay, thank you so much and have a nice